Today's paper is Scalable Object Detection Using Deep Neural Networks, also known as MultiBox. The proposed model predicts class-agnostic bounding boxes, meaning the model knows where the objects are but does not know which class it belongs to. The object detection problem is defined as a regression problem where the model outputs several bounding boxes with each having a confidence score. Let's look into the method. The model uses a deep neural network to produce a fixed number of bounding boxes. The value of k, which denotes the number of boxes, is set to 100 or 200 in the paper. Together with 4-dimensional box output, a confidence score in range between 0 to 1 is predicted. So in total, the output dimension becomes 5, where in one output branch, 4 dimensions are used to represent top left and bottom right corners, and in another output layer, one-dimensional sigmoid output is used to predict the confidence score. When training the network, only a subset of predicted bounding boxes are used because there are a limited number of ground truth objects. The equation right here represents L2 bounding box loss between predicted box I and ground truth box J. The value of xij is used to identify whether there is a connection between predicted box I and the ground truth box J. If a match is valid, the value of x becomes 1 and calculated loss is used to train the network. Similarly, cross-entropy loss is used to train the classification output. As value of xij was used to consider valid matching pairs in the earlier equation, it is used in the same manner in equation 2. The final loss term is shown in equation 3. Two losses are summed together, and the alpha term here is used to balance the matching loss. In the experiment, authors state that the value was set to 0.3. Now, to find valid matches between ground truth and prediction box, a variant of bipartite matching is used with the loss term defined earlier. The complexity of the algorithm is polynomial, but this isn't a big problem in this paper because only a limited number of boxes are used for training. Now, let's look at the results. The model was trained on VOC2012 dataset and was evaluated on VOC2007 evaluation set. For evaluation, the authors separately trained DeepNet-based classifier and used it to evaluate object detection model. The achieved mean average precision is 0.29, which is on par with other state-of-the-art. The model does not achieve top mean average precision scores on all classes, but most of the performance is on par with other state-of-the-art models. Lastly, here are some qualitative results. A link to the paper and some useful resources will be provided in the description. That's all for today, and I'll see you next time with a new paper.